Uh, Good morning, almost good noon. Welcome to all. It's a pleasure to be here. My name is Dan Blumberg. I'm chairman of the Israel Space Agency. My background is planetary geology, I have to say, not the moon. Most of my work has been Earth, one of the planets, Mars, Venus. But I'm happy to talk about our plans for the moon over here as part of the Israel Space Agency. First of all, I'll say that we signed the Artemis Accords. We're part of the program. We're also involved in Artemis, and I'll show you one of the examples as I move along. I was about to hide some of the slides, but the menu's in Italian, and I wasn't sure there. So I'll just skip slides as I move along. I apologize ahead of time for that. And why am I not moving? Yeah, I was going to start off with this slide, which I always like to start off saying that, remote sensing is not something new. We've been doing this for quite a while, and I have a lot to say about this pigeon in the picture, but I won't do that. I'll give a talk later on about pigeons and space. Israel is a relatively small country. We have a long legacy with space missions, launching, actually building, launching, operating, and eventually taking them from womb to tomb. Our first satellite was launched in 1988. Since then, as you can see over here, we've launched quite a few satellites. There are actually more than are on this slide because in the last 2 years, we've launched quite a few more satellites. The two that I wanted to mention started off with 1988, starting our legacy, and 2019 was the Bereshit mission to the moon. Our first mission that we operated going out of, not looking at Earth, out into a deeper part of space. Bereshit, by the way, means Genesis. I'll say that. I'll get back to Bereshit in 1 second. I'll also say that the space agency itself is a lean space agency. I work at a university. Most of our employees or members of the agency work at universities, and all of the operation is done through nonprofit organizations or academia. I'll skip that one also because everyone is in this room. You all know who's been to the moon, and everyone's been talking this morning, and I thank everyone that spoke this morning. So I'll start off with this picture, 2019. Some of you will probably say that Bereshit 1 was a failure, a disaster. But I want to say there were two objectives. One was get to the moon, and the second one was hop on the moon. We did both of those. The hop wasn't exactly what we had planned. A little harder landing than we had planned, but it was achieved. This is a true picture from Bereshit 1, taken during the landing. We have quite a few more pictures. I like to show this one to show that we actually took these pictures. We have another one of the lander as it goes down with some text that was on it. I'll skip that, and I'm going to go and say, with Bereshit 1, we started. That's not the end of our program to the moon. So now we're planning on going on to Bereshit 2, another lunar mission, another educational program. So Space IL is the nonprofit organization that was founded by 3 young engineers sitting in a coffee room, looking at the Google X contest, pulling out a napkin and starting to draw a lunar lander on that napkin. By the way, I'm from Ben-Gurion University. I have to say, 2 of these engineers are graduates of Ben-Gurion University. I just had to say that. I get paid based on how many times I say Ben-Gurion University. So the mission ended, Bereshit 1, on April 11th, 2019. By the way, during EGU of 2019. But that's not the end. There were several achievements in Bereshit 1. First Israeli spacecraft to go to the moon or go beyond Earth. The fourth country to touch upon the moon was a lander. Seventh country to capture the moon, first capturing photographs. First non-governmental organization to fly to the moon. And, you know, there's a lot of pride associated with it. I think that the best part of it is the kids, the thousands of children that were involved in the planning, in learning, and we try to inspire them with this mission. I mentioned there's another photograph with some text, and you can see over here, small country, big dreams. That's also a picture taken just before the crash on the moon. You can see the lander over there about to touch. So I said Bereshit 1 is the end of 1 and the beginning of 2. So we're going now on to Bereshit 2, which goes on from where the previous mission ended. Bereshit 2 will look slightly differently. It's planned to be a 3-part mission, an orbiter and 2 landers. 2 landers that will be released from the orbiter, landing on 2 separate locations on the moon, a longer mission than Bereshit 1. Each one of the modules will have scientific experiments. Most of the experiments have been selected already, not all of them. There is a funding issue that we're still dealing with. There are any philanthropists in the room? There's a box over there to put the, but we're getting there. We also want this to be a global mission. We want other partners in this mission. We're going to keep children involved, kids. The plan is to have them involved in the mission itself as part of the controlling of the orbiter and taking pictures while it's up there. And that's part of the plan. Now we can say double, triple the effectiveness, whatever number you give over there is probably true, but that's the objective. We want to do more than we did in the previous one. We want to open it to more international partnerships and give the partners a strong hand in controlling the mission. So a little bit about what's going to happen on Bereshit 2. The landers are going to be the smallest landers ever. You'll still see. They'll be a little bigger than CubeSats. We're already designing them. There'll be a control room where children can be involved in taking pictures on the orbiter and a few other things that will happen. Just to give you a feeling of what the plan is, you have this slide over here. Said I'm going to run through a few of the slides. A few of the experiments. One is a biopharma experiment on drug stability in deep space, important for the Artemis missions. This is run by the Hebrew University in Jerusalem. They're going to have a spectrometer within the Raman spectrometer on the mission, and they're going to be testing drugs. Again, I said I'll mention Ben Gurion University. This is a hyperspectral camera that we designed using compressive hyperspectral sensing, which means that we can reduce the size of the hardware dramatically, and it'll be designed to fly on the orbiter and take hyperspectral images of the moon's surface. Another one is a seedling project run by 3 Australian universities, where they're going to test the seedling of seeds on the moon. I'm running. We signed an MOU with NASA to be part of this mission recently, by the way, in January. DLR are also now involved in collaboration with us on Bereshit 2. I want to skip to 2 other things. Radiation is a concern for any human flights to the moon. On Artemis 1, I'll be 1 minute. Artemis 1, we had an Israeli radiation vest designed by the space agency and STEMRAD, the Astrorad that actually flew already on one of the dolls, whatever you want to call them. And we're examining the results at the moment. It's extremely lightweight, protects the bone marrow on the astronauts. You can see the pictures. And another experiment is the Hoppler, which is a drone that can be flown into the lava tubes in the moon of a company called WeSpace in Israel that we're funding. So that's the design. It can actually fly. And I'll stop over there for the sake of time.